So the equation that relates these three measurements, angle, radius, and arc length, is that the angle, theta, is equal to the arc length divided by the radius. So this is exactly how we'd set it up if we were looking for the angle. But if we want to find the arc length, which is what we want to focus on today, we take that equation, and if we multiply both sides by r, then r divided by r is 1, and then we are left with the equation r times theta is equal to the arc length. So then anytime we want to find the arc length, all we're going to do is multiply the radius times the angle measure. But because we're looking for a length, this angle measure has to be in radians. We cannot use an angle measure in degrees to get a length. So we're going to do two examples together. The first one is if we're already in radians, and the second one is what happens if we're in degrees. So, example number 1. We have our circle. Our angle measure is pi over 4. Our radius here is 5 centimeters. And we are looking for the length of this arc. Bless you. So the arc length S is equal to the radius of 5 centimeters multiplied by the angle measurement pi over 4. That's all there is to the formula. But let's talk about how we're going to express our answers. There are times when we want to give the exact answer. And your IXL lesson today is going to ask you for the exact answer. So, when you have a calculator, anytime you hit this pi button, so bright. Alright, this is just aggravating me a little bit. Let's try and fix it. No, we still can't see this, can we? Alright, well if you on your calculator would hit the pi button. I don't know why it's not showing up. It's on there. Your calculator starts to give you a decimal, but that is not the actual amount for pi. Pi is a non-terminating, non-repeating decimal. So it only stops because it's at the end of the screen. Whether you round it to the tenths or the hundredths or the thousandths, even if you write all the digits you see on the screen, you are still rounding. So once you press that pi button, you are not having an exact answer. So the way to have an exact answer is to leave the pi with the pi symbol. So if you are asked for the exact answer would be 5 pi over 4 centimeters. Well, if this actually was your arc length, and let's say you were decorating this with some ribbon, and so now you're going to go to the store and buy the ribbon that you need, it is not going to help you to go into the store and know that you need 5 pi over 4 centimeters of ribbon, right? You're not going to know what to buy. So there are times when we want to change this to a decimal and do 5 pi divided by 4, and then maybe round that to 3.9 centimeters. And then when you go to the store, you know that if you buy 4 centimeters, you will have enough for your project, right? So, yes, there are times to change it to decimal. There are other times when you would want an exact answer. So this guy is exact. This is an approximate, it's a rounded answer. Alright, you good with that? Thumbs up if yes. You all good? Alright, what if they give you theta in degrees? So if we take a look at this circle, it's got a radius of 8 feet, 72 degree angle, and we want this arc length. So the first step is going to be to convert it to radians. So now we're in feet. Maybe this is a section of fence that you're going to put up on a curved area. But the first thing that you have to do is to take your degrees and convert it to radians. So when you're finding arc length, you first have to convert your degrees to radians. So we know how to do that. We're going to take 72 degrees, and we're going to multiply by pi over 180, because pi radians and 180 degrees are equivalent. And we get 72 pi over 180. But we have to simplify. And the number 36 is the greatest common factor. And so we would have 2 pi over 5. And that would be your exact answer. And then if you were going to go to the store and buy that amount of material for your fence, then you would need to get, press that right, 1.26 feet of fence. Thank you. I was looking at the 8 feet and looking at that and going, that cannot be right. 2 pi over 5 is equal to your angle, theta. So that tells us that our 72 degrees is equivalent to 2 pi over 5 in radians. And now we need the arc length. So now we need to do 2 pi over 5 times 8 feet. So then we would have 16 pi over 5 feet. This would be our exact answer for the arc length. So that's your exact answer. If you were going to the store, you would need 10.1 feet of materials to make your fence. Which, back to our picture now, that makes sense. If your radius is 8 feet, you're going around that far, yeah, 10.1 feet. Alright, so that is all there is to arc length. Alright, so now we are going to look at area of a sector. So a sector is a section of a circle. It has the vertex at the center of the circle. But basically, if you would just think of a sector as a slice of pizza. So the vertex is at the center of the circle, and then that angle goes out, intersects the circle, and forms this little area, and that's a sector. Comes from the same word as section. So like when you have band sectionals, it's part of the band that's rehearsing. If you go to a concert or a sporting event and you're seated in section 112, that's a part of the arena or a part of the stadium. So a sector comes from the same word as sectional. It's a part of something. So, who likes pizza? Anybody here like pizza? I like pizza. What's your favorite pizza topping? Bacon? Where's the pepperoni lovers? Plain cheese? Sausage? Okay, great question. Does pineapple belong on a pizza, yes or no? I'm a yes. I'll put pineapple on my pizza. Alright, so we're going to look, why is Ms. Carter talking about pizza? Because a sector is like a slice of pizza, and we're going to create a very real-life scenario to look at area of a sectors. So, let us say that Rachel has this pizza right here that she ordered, and she eats this part of the pizza. Alright, meanwhile, Karina orders this pizza, but she eats this sector of the pizza. Let's think about, what do we need to know to figure out who ate more pizza? I mean, we can say, well, Rachel ate one piece, Karina ate one piece. So did they eat the same? Or we could say, well, Rachel ate a fourth and Karina ate a half, so I guess Karina ate more. Is that necessarily true?
No, that one's smaller.
Oh, this one's a smaller pizza. We could say, oh, well, Rachel had a bigger pizza, so she ate more. Not necessarily, right? So we need some more information. Do you know how they measure pizzas? By the diameter, right? So if you'll see a sign, and let's say this pizza, if this is a 16-inch pizza, right, and you'll see it sometimes on the wall of the pizza place, it'll be 16-inch pizza, or the menu might say 16-inch pizza. That 16 is telling you the diameter. So if the diameter is 16 inches, what's the radius? 8. So 16 inches, that's fairly common for a large size pizza. Well, then let's say this pizza has a diameter of 12 inches, as many small pizzas do. What's the radius of this guy? 6 inches. So if you're eating pizza, are we talking about the outside edge, the circumference? No, that would be it would be the area, right? So area of a circle is equal to pi r squared. No, pi r round. Oh, I didn't even get any groans in here. Pi r squared. No, pi r round. Okay. Lame math joke. Okay, trying. It's a rough crowd in 4A today. 4B, sorry. Alright, so let's look at Rachel's entire pizza. That would be pi times 8 squared. But Rachel didn't eat the whole pizza. How would we figure out the area of the part that Rachel ate? What fraction of the pizza did she eat? A fourth. So couldn't we take the whole pizza and times it by a fourth? And that would tell us how much she ate? Does that make sense to you? Alright, so let's do that. We'd have 64 pi times 1/4. 50.27 square inches worth of pizza. Alright, well I wonder how that's going to compare to the pizza that Karina ate. So Karina's pizza is a circle, and so the complete area is pi times r squared, which in this case is going to be 6 squared. But for the part that Karina ate, she didn't eat the whole pizza. What part did she eat? A half. So does it make sense that we would take the area of the whole circle and times it by a half to get the area of that sector? So that area comes out to be 56.55 square inches of pizza. So we can see that Karina eating half of a small pizza actually came out a little bit more than Rachel eating a quarter of a large pizza. But maybe closer to each other than we would have guessed. This type of calculation also useful for if you're trying to figure out which pizza is the better buy, right? You could find the area of the pizza and then divide it by the price, because sometimes the smaller ones are actually cheaper than the larger ones. Sometimes it's better to buy the large or too small, real life decision making happening. Alright, so look at the main idea, the big concept. We found the area of the whole circle and we multiplied it by a fraction, right? Area of the whole circle multiplied by a fraction. Well, that's what we're going to want to use for all of our sectors. But they're not all going to be nice little fractions like a fourth or a half. So let's just look at some of the less obvious ones. So let's say I have a sector and my angle measures 75 degrees and my radius is 2 feet. So I'm going to take pi times 2 squared, and then I'm timesing by a fraction. Well, remember, what is a fraction? How is a fraction, what is it depicting, right? It's a part over a total. So the part of the circle that our theta is 75 degrees, and the whole circle is 360 degrees. So that's going to make our fraction. Part over total. So if we want an exact answer, we might want to go ahead and simplify this first. Let's see. $360 divided by 5 is 72. And 75 divided by 5 is 15, right? Oh, but 15 and 72 are both divisible by 3. So divide that by 3 and we get 5, and divide that by 3 and we get 24. So then I've got pi times 4 times 5 over 24, and 4 goes into 4 once, and 4 goes into 24 6 times, 5 pi over 6. That's me doing a lot of simplifying in my head. I can literally take 4 times 75 divided by 360 and get this decimal, 0.833333, and then use the math button of my calculator and go over to fraction, and I'll get 5/6. So that represents the area of the sector. And that would be an exact answer because we're leaving the pi in there. Alright, well, what if we have a circle that starts off with an angle measurement in radians? So if I have 3 pi over 4 radians for my angle and a radius of 10 feet. So my area of my sector is going to be pi times 10 squared times a fraction. The fraction is going to be part over total. Well, the part that I have is 3 pi over 4. And the total circle in radians is 2 pi. Does that look very weird to you, having a fraction inside of another fraction? It might, but you should get used to it because you're going to see this a lot. This guy is called a complex fraction. So when you have a fraction inside of another fraction, like our entire numerator itself is a fraction, that's called a complex fraction. A fraction bar, another cool vocabulary word for you, it's called a vinculum, Latin word. And to be able to simplify this fraction, you just have to understand what division actually means. So let's just go back to basics. Let me actually turn my page so that I've got room here. And when we're going to divide something, what does that even mean? Let's look at a few really basic examples. What if I have the number 6 and I divide it by 3? What do I get? Well, what happens if I take 6 and I times it by 1/3? I get 2. Interesting? Think it just happens with 6 and 3? Are they some kind of magical numbers? What if I take 8 and divide it by 2? What do I get? What if I take 8 and I times it by 1/2? What do I get? You see the relationship here? Division means multiply by the reciprocal. That is the mathematical definition for division. We don't even need to have a division button on our calculators. We don't ever have to actually do division. Every division problem can be turned into a multiplication problem. So, since I had 3 pi over 4 divided by 2 pi, written out like that, and it might make more sense to you if I write it out 3 pi over 4 divided by 2 pi. The way to simplify that is to take my 3 pi over 4 and times it by the reciprocal. The reciprocal of 2 pi is 1 over 2 pi. Pi divided by pi makes 1, so that is 3/8. So I'm going to have pi times 100 from 10 squared times 3/8, or 300 pi over 8, and then if I divide by 4, I would get 75 pi over 2. Looking at this 3/8, we go back to our picture. Remember what our sector looked like? It was 3 pi over 4. Well, what happens if I cut this like a pizza? Here was my original. Sorry, you guys couldn't see what I was doing. Isn't that 3/8? 1, 2, 3 out of 4, 5, 6, 7, 8. It's 3/8. The angle of 3 pi over 4 did represent 3/8 of the circle. And dividing by the reciprocal, that's just the number crunching that gets you there. Alright, so on your iExcel, there's a link, but for whatever reason I messed up the link, and it's just going to take you to the iExcel Geometry homepage, so you need to know this. It's in Geometry, it's U6 is the lesson. U6. It's called Area of Sectors.